Problem number 33, continuing with the one-step, two-step equations. So we're still going to be using SADMAP, which we remember is our order of operations backwards. We should recognize parentheses, exponents, multiplication, division, addition, subtraction. When we solve equations, we work those process backwards. So we want to isolate the variable, which means we're removing everything from it, working in this order. Is there any subtraction in the problem? Yes, there is, so we want to undo it. We undo the negative 5 by adding 5 to both sides. And so we were going to end up with 6.8 plus 5, which gives us 11.8, being equal to 1.2x. And so we now have 1.2 getting multiplied to x, and the opposite operation is going to be division, so we will divide by 1.2. Anything divided by itself is 1, so that leaves x on this side of the equation. Remember that to balance out the equation, we're going to divide the opposite side by 1.2. So 11.8 divided by 1.2 gives us 9.83, repeating. Question 33. Question 33 has an expression in the numerator. We've talked a couple of times this year about having expressions in the numerator. When there is an expression in the numerator, we are going to pretend like it's in parentheses. Now, since it's in parentheses, that's the last thing in my order of operations backwards, so we're not going to touch it until we've done everything else. So x minus 5 in parentheses over 2 is equal to 14. Remember, every fraction is division, so we can do the opposite of division to clear out the 2 in the denominator. The only thing that will clear out a 2 evenly is a 2 in the numerator, so we're going to multiply by 2, and those will simplify out. Again, what we do to one side of the equation, we must do to the other. So now we have 28 on my right side, and the only thing left on the left side is this x plus 5, or x minus 5 that we put in parentheses. And so since it's the only thing left, we no longer need it in parentheses. So we'll add 5 to both sides, and x is now equal to 33. Number 35. Number 35, we see that f is in the fraction with 9. That's division. But this term is getting subtracted from 5. So we need to deal with the subtraction process that's taking place here. And really, it's not so much subtraction as, remember, this term here can be rewritten as negative f over 9 plus 5. So we have a positive 5 there that needs to go. Now, I'm not going to expect you to rewrite the problem, but you can if it's going to help you to remember that that 5 is positive. So the first thing we're going to do is subtract 5 from both sides. So 13 is equal to negative f over 9. Now, I've told you throughout the year, anytime you have a negative sign in front of a fraction, it's telling us that that fraction is negative. Now, it doesn't matter if it's sitting in front of the sign, if it's sitting in front of the numerator, or if it's sitting in front of the denominator, the fraction is still negative. I tend to recommend that you keep it in front of the numerator just because it's going to make life easier as you are solving problems. So we're going to go ahead and assume that the negative is in front of the variable, and we will multiply by 9 on both sides of the equation to clear out the denominator. And so we end up with 117 is equal to, remember that we have left a negative f. And we've talked before about having a negative variable in class. You cannot have a negative variable left as a solution. You can have a negative value for that variable, but you cannot have a negative solution. a negative variable. So our operation taking place here, we have a negative number multiplied by f, so we're going to divide by -1, so that we now have a negative divided by a negative, which becomes positive, equaling a positive divided by a negative, which becomes negative. Now eventually you'll get used to doing this so much that you won't have to show the work for that process anymore. You will just realize that that's going to become positive and this will become its opposite, negative. Number 36. Again, we have a value in the numerator that's an expression, so we're going to put it in parentheses. And now I'm going to multiply both sides by 2, so that my 2 will simplify out, and we're left with e minus 4 being equal to -16. We're down to a one-step equation now, so we can add 4 to both sides, and e is equal to -12. Number 37. All right, number 37. We got fractions and decimals. Generally not preferred to deal with fractions and decimals. I prefer for you to deal with one or the other. So I'm going to go ahead and change this 8/5 into a decimal. So 8 divided by 5. 5 goes into 8 one time. Now 5 goes into 36 times, so we have 1.6x minus 3.2 equals 48. Sorry, 4.8. That's just going to simplify the problem a bit. If you really wanted to, remember we talked about clearing fractions. We could certainly clear fractions in this case. And that is simply the process of multiplying both sides by a common factor that will eliminate the fraction. In this case, we need to move the decimal place one place. And we do that by multiplying by 10. So if I multiply every term by 10, we'll clear the fraction. 10 times 1.6 is 16x, minus 10 times 3.2, which is 32, equals 10 times 4.8, which is 48. And so now we just have a two-step equation with some relatively normal whole numbers. So 48, we want to get x by itself. This is multiplication. This is subtraction. So we want to undo the subtraction first by adding 32. So 16x is equal to 80. And we divide both sides by 16, where x will now be equal to what appears to be 5. Number 38. Number 38, everything's already in fraction form. We may as well leave it there. Plus, we notice that there's a 3 in the denominator here. And 3 times 3 gives us 9, which means we could convert this fraction to a value that has 9 in the denominator. And anytime we have 9 in the denominator, we know that we're going to end up with a repeating fraction, unless it goes into the numerator evenly. And so we don't want to deal with a repeating decimal. We don't want to deal with a repeating decimal. So we're going to go ahead and work with this problem in fraction form. Now, just as we cleared decimals in the previous problem, we can clear fractions by the same process. Here, we want a number that is a multiple of these denominators, but preferably the smallest possible multiple. And so we call that our least common denominator, or least common multiple. And so I have a 5 and a 3. Common multiple that is the smallest would be 15. So we're going to multiply every fraction by 15. So 15 times 1 is 15, divided by 5 is 3. 15 times 2 is 30, divided by 3 is 10. 15 times 4 is 60, divided by 5 is 12. And now we should notice this problem cleaned up very quick and easy. Just a two-step equation with some relatively normal whole numbers. And so we're going to look at our operations. We have multiplication and we have subtraction. I want to undo the subtraction first, so I'm going to add 10 to both sides. And we are going to divide by 3. X will be equal to 22 over 3. Now, since it's got a denominator of 3, I know that unless this numerator is a multiple of 3, it's going to give me a repeating fraction as a solution. So we're just going to leave the answer as a simplified improper fraction. That answer is simplified improper. It will be sufficient.